Alright, so our next question comes from 4.32 own. It wants us to look at the linear time invariant system S. It has an impulse response of h of t. And we need to determine the output of S for each of the following inputs, okay? So the first thing that we must do is find the Fourier transform of h of t, and then we can use that Fourier transform for all of A, B, C, and D, which I will do in this video. Okay, so first, the Fourier transform, I'm going to rewrite h of t. So h of t is equal to sine 4t minus 1. Okay, all divided by pi t minus 1. Alright, so what you're going to need is your sheet here, okay? You need to look on the x of t side, and you're going to see something familiar to this equation, which is going to be sine big W t over pi t. Okay, so we need to see how this h of t has been changed from this original sine wt over pi t, so we can see what the Fourier transform will look like. Okay, so first we can notice that h of t has been multiplied by 4. So sine of 4t all over pi t, and that would give us, originally first, let's show what this would give us. X of j omega is equal to 1, 0, omega, big W. Oh, that's ugly. Big W, okay? So to see how this changes the original, okay, we can see that big W right here is equal to 4. So big W is equal to 4. So then now our new x of j omega is going to be equal to 1, 0, absolute value of omega less than 4, absolute value of omega greater than 4. Okay? So now we have to deal with the time shift. Okay? So doing a time shift is, oh, I'm sorry. I was looking at the sheet. So doing a time shift here, let's see. X of t minus t naught moving to the frequency domain is going to be e negative j omega naught omega t naught times the x of j omega. Okay? And since sine 4 of t minus 1, so this is equal to your t, this is minus your t naught, so t naught is going to be equal to 1. Plug that 1 into there, and our new x of j omega is going to be multiplied by e to the negative j omega, okay, which you're just multiplying by 1. So 1 times e negative j omega, this is the 1 in here for the t naught, and 0, and omega less than 4, omega greater than 4. Okay, so I was writing this as x of j omega just out of habit, but this is actually h of j omega, okay? H of j omega. And this is actually your final h of j omega that you're going to be using throughout the rest of this problem, okay? So let's look at our first value at A. X of t is going to be equal to cosine of 6 pi oh no, just 6t. 6t plus pi over 2. Okay, so you need to take the Fourier transform of x of t, okay? Because when you're solving a linear time invariant system impulse response, it is the same as just multiplying the two signals here. So, so let me show you what I'm talking about. So y sub j omega, this is S, or this is going to be the output of system. Okay, y sub j omega, and when you need to find the output response, it is equal to x of j omega, which we are about to find, times h of j omega, which we have already found, okay? So this is going to be the equation that is used throughout the rest of these problems. And then once you find that answer, it wants you to find the impulse response, and it's going to want it in terms of t, okay? In terms of t. So let's go ahead and solve this. So we need to find the impulse response for x, we need to first find the Fourier transform of x of t. So x of j omega can be found just straight from looking at your sheet. Let's go ahead and look at this. So from our sheet, we see that cosine omega naught t will give us pi times delta of omega minus omega naught plus delta omega plus omega naught. Okay, so we need to find out what omega naught is in this in this part, and omega is just going to be the radians per second in a cosine signal. And I don't know if you know this. I'm going to write this out for you. Cosine omega t plus or minus k sub t. Okay? Oops, not k sub t. Plus or minus the angle. Okay? This is going to be your omega. Okay? And as we can see, omega naught is going to be 6 in this case, okay? So x of j omega is going to be equal to pi of delta omega minus 6 plus delta omega plus 6. Okay, it's that easy. So now we get into the part where it's going to start taking a little bit of work. So we're going to have, bringing this down here, y sub j omega is going to be equal to x of j omega, which is this, pi delta omega minus 6 plus delta omega plus 6. Okay? And then all of this be multiplied by our h of j omega, which is going to be e to the negative j omega. Okay, so now, I bet you're thinking to yourself, how are you supposed to do this? Well, first of all, you have to realize that a delta function only has values at certain points. So, these two only have values at 6 and negative 6. 6, negative 6. And obviously the magnitude of it is just going to be pi, because you're multiplying by pi, okay? That's the height. May not be drawn to scale, but, okay? It's going to be 0. So now we need to multiply by e to the negative j omega. But e to the negative j omega right here is only defined from negative 4 to 4. Okay, so we're just going to draw some ugly function for e to the negative j omega. So 4 and 4, negative 4. So that's the only part where this function is defined. And as you can see, x of j omega is only defined at 2 single points, and so you're basically multiplying it by 0, okay? Because there's nothing to multiply by. It's 0 right here. Okay, so 0 times anything is just going to be 0. So y, so j omega is equal to 0, which thus means the Fourier transform of 0 is going to be 0. Okay, so that's your answer for A. Alright? And I hope that you can see that these 2 points are the only points where x of j omega is defined. Okay? So now, if this were to extend out to here, then there would be a value right here that y sub j omega would equal, but it doesn't. It doesn't extend that far. It only extends from negative 4 to 4. Okay? So now we are going to move on to B. Let me get the question pulled up. So B, alright, it's looking like a summation. That's going to turn, okay, so infinity, 0, 1/2 to the k times sine 3kt. Okay. Alright, so let's go ahead and look at our sheet again. Let me fix this up for you guys. Oh my gosh, that was even worse. Okay, so we need to find the Fourier transform of this, okay? So if you look at your sheet, sine omega naught t is going to be equal to pi over j delta of omega minus omega naught minus delta omega plus omega naught. Alright? And as you can see here, again, sine of omega t plus or minus an angle, omega naught is going to be equal to kt. Okay? Alright, so let's go ahead and multiply these two. So 1/2 1/2 to the k times pi over j delta omega minus 3k minus delta omega plus 3k. Okay. So now all we need to do is do the summation of this. It's 0 to infinity, but with some quick deductive reasoning, you can tell that h of j omega is only defined from negative 4 to 4. And remember, you're finding the impulse response y of j omega is equal to x of j omega times h of j omega. Alright, so you're going to be multiplying these two again, and it obviously is only going to produce a value if they both have a value at the points where they are being multiplied at. Okay? So that's going to stop you from doing infinitely amounts of this. Okay? So let's just go ahead and do 1/2 to the 0 times pi over j delta omega minus 0 minus delta omega plus 0. So that's one value. That's still within the negative 4 to 4 range. okay? Because you're at 0. Okay, 1/2 to the 1 times pi over j delta omega minus, so 3 times 1 is going to be 3 minus delta of omega plus 3. Okay, and as you can see here, this next value is going to be 1/2 squared times pi over j. Let's make this prettier. Pi over j times delta of omega, so it's going to be 3 times 2, which is going to be 6. And immediately you can tell that this is not going to be defined at the same points as h of j omega is going to be defined, so it's just going to be equal to 0. Okay? So, go ahead and, so this is not defined. Okay? Okay, so we need to multiply this times h of j omega, which is e to the negative j omega. Okay? So it is just going to be 1/2 to the 0 is just going to be 1 pi over j delta omega minus delta omega plus 1 pi over 2j delta omega minus 3 plus minus delta omega plus 3. Okay, and since these are the only ones defined, these are the only ones you have to multiply by e to the negative j omega. Okay, 0. So this is the only one that's left. Okay, so since you are only left with this right here, you should notice something, okay? You have something that can be changed back to sine, which this can be changed back to sine, and then this is just a time shift. Okay, so we're going to change it back to sine. It's going to be sine of 3t minus 1 to the 1/2. Okay, that's because of the time shift. Actually, I'll erase that and explain it more. Okay, so just this right here, this will give us 1/2, because the pi over j is needed to change it back to sine. So that gives us 1/2, and then omega minus 3, so that's going to have to be, the 3 is going to be multiplied by the t in the sine function. Okay, so sine 3t. Okay, and this is t minus 1. Okay, so then, well, it's not t minus 1, it's just a minus 1 shift. Okay, from looking at your sheet. So then you put these two together, you're at 1/2 sine 3t minus 1. Okay, so this is y of j omega. This is us changing it back to the time domain. So y sub t is now equal to this, and this is your time impulse, and your time invariant impulse response of the system. Okay? So now we are going to do part C. Let me get it pulled up here. Part C. Oof. Oh, it doesn't look that bad. Okay. Part C. So x of t is going to be equal to sine of, sine of 4 t plus 1 all divided by pi t plus 1. Okay, so you're going to need, so there's two ways to do this. So you can analyze it just by looking at it, which I can already kind of see what's going to happen, or you can actually work it out. I'm going to show you how to analyze it just by looking at it, because you need to learn how to do this to save you a bunch of time, especially on the test when it gives you nasty problems, okay? So, when you take the Fourier transform of this is just going to be x of j omega. It's going to be some step function 1, 0, blah, 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 okay? And you're going to have to multiply this by e to the negative j omega. Well, you can already tell that when you multiply this by e to the negative j omega, it's just shifting it again, okay? So it is x of j omega times e to the negative j omega, okay? That is a time shift. So when you go to switch it back, it's going to be x of t, it's going to be x of t minus 1, because that's a time shift. This is a time shift of 1 to the right. Okay? You need to be able to see this pretty quickly, okay? So then you can just go ahead and plug in t minus 1 back into the original x of t, and you will have your impulse response answer, okay? So your new y sub t is going to be equal to sine of 4 of t minus 1 plus 1 all divided by pi t, that is ugly, t minus 1 plus 1. And when you simplify this, this is going to be sine of 4t, because that cancels, all over pi t, because that cancels. So this is your impulse response. This is y sub t. Okay, just in case you didn't follow, go back through it real quick. Okay, so you're finding your x of j omega. Okay, that is your Fourier transform, and it's going to be in this type of form, but you're just going to be multiplying it by e to the negative j omega, which is a time shift in the frequency domain. So you need to change it back. So this is your y sub j omega. So this is going to be your y sub t, which is equal to that. And we are just plugging in x of t minus 1 to get our y sub t, which is our linear time invariant impulse response. Okay? Part D. Part D, let's see here. That doesn't look bad at all either. Oh, cool, it's in the same format, so you'll be able to do the same exact thing we just did for C. Okay, so sine of 2t over pi t all squared. This is x of t. Alright, so I know for sure that you're looking at this like, this would suck to do. Okay, but it's really not that bad. Especially since we can do the same analysis by just looking at it, okay? So we know x of j omega is going to look like some type of Fourier transform. Okay, blah, 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 blah. All times h of j omega. Okay, so we're going to have blah, 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 blah times e to the negative j omega. Okay, and like I said, it is still just a time shift. So it's going to be x of j omega times e to the negative j omega, which when changing it back, this is y sub j omega by the way, which when changing it back to y sub t is going to be equal to x of t minus 1. Okay, so you just plug in t minus 1 in for t, and so your y sub t is going to be sine 2 t minus 1 all divided by pi t minus 1 all of it squared. You save so much time when you can do analysis by just looking at it. Okay, so you have to really kind of pick up on these types of things, okay? And let's see here. That's pretty much it. I will see